All right, so our first word is concentration. Again, a lot of you said on your definitions that that's like thinking hard about something. Yes, yes, it is, but that's not the concentration we mean here. So the definition we're going to use for concentration is how tightly packed in the molecules are. So when we look at a solution, which we're going to be looking at, there's going to be water molecules and other molecules. However tightly packed they are describes its concentration. Molecules prefer to be far apart. So when you put food coloring or Kool-Aid powder into water, they're going to want to spread out and be as equidistant is the word they use for it, as evenly far away as they can. When we talk about concentration, it's not the amount of molecules, it's how close they are. But you have to think of both of those things at once. They want to be far apart, but they can only spread out in the liquid that they're given. So if you put a lot of molecules in, it's going to be much more concentrated. High concentration means there's a lot of whatever type of molecule. So if it's a saltwater solution, there's a lot of salt molecules. If it's lemonade, there's a lot of lemon juice and sugar. If it's Kool-Aid, the Kool-Aid sugar. Whatever you're talking about is a lot of that type of molecule. It's kind of like density, but it's in a liquid. If we were to draw it, this beaker over here has a high concentration of whatever particles we're talking about. And this one has a low concentration. And even if I were to take just the same area, right? Like just this corner here and this corner here, right? It's still, we have 1, 2, 3, 4, whatever, let's say sugar molecules, and only one over here. So pause this where you need to. Make sure you have this Frayer card copied because we are going to be coming back and talking about it. I'm going to move on to the next term. You come back to this if you need to. Our next term is solution. And again, it's not like an answer to something. That is solution, not in this context. Solution in this context is a liquid mixture made of a combination of solute and solvent. Now, I just used two other words in the definition that we haven't defined yet. So, or we haven't done Frayer cards yet for, and we're not going to. We're just going to include them all on this one. A solute is the solid part of the solvent. Is the solid part of the solution. The solute is whatever gets dissolved. So salt, sugar. These are going to be our two most common solutes. The solvent is the liquid part of the solution. What does the dissolving? So we learned, holy cow, unit 2, that water is the universal solvent. If something's dissolvable, it'll dissolve in water. For everything we're going to talk about in cell membrane and transport and all the things we're talking about, molecules moving and being dissolved, we're going to be dissolving them in water. So for this unit, solvent is water. So sometimes it's a little easier if you think of that V. You could keep that V going to make a W. Solvent is water. So any little trick you can give yourself. Solute, salt, sugar, etc. I know the words sound similar and that sometimes it's a little frustrating. Examples, salt water, lemonade, iced tea, Kool-Aid, Gatorade, any of these things are solids that have been dissolved in a liquid. We call that a solution. So there's no drawing for this because it would just be the ones we had on the last one, and there's really no non-example either. So if you think back to your last Frayer card, you drew two solutions. You drew a solution with a high concentration of sugar, and you drew a solution with a low concentration of sugar. So when I ask about a solution, we're typically going to follow up with asking about the concentration. Then again, we're going to bring it back to cell membrane. The solution outside of the cell compared to the solution inside of the cell. The concentration outside of the cell compared to the concentration inside of the cell. Once you have those two Frayer cards done, you're going to move into a Nearpod activity where I'm not going to say it's cool because it's school, but you're going to get to practice like a virtual lab demonstration where you get to make different solutions and see the effects, or the ways that you can change it. So go back, pause, rewind, make sure you have both of these Frayer cards copied. And if you have any questions, just send me an email and let me know.